In this video, we'll be looking at the meaning of mechanical advantage, velocity ratio, efficiency, and ways of maintaining machines. All simple machines are composed of three parts, which are the effort, the fulcrum, and the load. The effort, the fulcrum, and the load are the three basic parts that make up a simple machine. Mechanical advantage is defined as the ratio of the load to the effort in the machine. The ratio of load to effort in the machine is defined as the mechanical advantage of the machine. Scientists have a way of knowing if a machine is worth having, and there's no point constructing a machine that is not efficient. The work done on the load by the machine must be greater than the work done on the machine by the effort. If the ratio of the load and effort is greater than 1, it is called a mechanical advantage. And if this ratio is less than 1, it is termed a mechanical disadvantage. The ratio of load to effort is also called the force ratio. Again, if the force ratio is greater than 1, it is called a mechanical advantage. And if the ratio is less than 1, it is called a mechanical disadvantage. If the mechanical advantage of a machine is greater than 1, it means that the machine can overcome a greater load than the effort applied to the machine. Again, if the mechanical advantage is greater than 1, it means that that machine can overcome a greater load than the applied effort. But if the mechanical advantage is equal to 1, again, if the mechanical advantage is equal to 1, it means that the load is equal to the applied effort to the machine. But if the mechanical advantage is less than 1, it means that the applied effort is greater than the load. It can be termed a mechanical disadvantage. Mathematically, mechanical advantage can be calculated in a machine. For example, if a force of 80 Newton is used to overcome a load of 240 Newton in the machine. Again, if a force of 80 Newton is used to overcome a load of 240 Newton in the machine, what would be the mechanical advantage of that machine? Mathematically, to get mechanical advantage, we'll use the ratio of the load over the effort. Therefore, our load in our question is 240 Newton, while the effort applied is 80 Newton. If we divide 240 by 80, we'll get 3. So 3 will be the mechanical advantage of the machine. Note that the mechanical advantage has no unit in the machine. Next, we'll look at velocity ratio of a machine. It is the ratio of the distance moved by the effort to the distance moved by the load at the same time in the machine. The distance ratio of effort over the distance ratio of the load gives us the velocity ratio of a machine. While the percentage of work done to the energy supplied to do the work in the machine gives us the efficiency of the machine. Efficiency is equal to work output over work input times 100 over 1. Efficiency is the ratio of the load times the distance moved over the effort times distance moved. You can also say that efficiency is equal to the mechanical advantage, which is the work output, over velocity ratio, which is the work input, times 100 over 1. A perfect machine has 100% efficiency, which means that all the work done by the effort is used to overcome the load in the machine. For a perfect machine, the mechanical advantage must be equal to the velocity ratio. This means that there will be no friction in the machine. But in reality, the efficiency of a machine is less than 100% due to friction in the moving parts of the machine. Now, part of the force applied to the machine is used to overcome frictional force, and part is used to overcome the load. And some of the parts in the machine might be old and inefficient. As such, some of the energy input will be converted into noise and some into heat, thereby leading to incomplete combustion taking place in the engine of the machine. Due to these two reasons, there is no perfect machine anywhere. And again, friction is the force that opposes the motion of moving parts of machine. This friction affects the efficiency of a machine, thereby leading to wearing and tearing of parts of a machine. So therefore, there is no perfect machine due to friction. Next, we look at maintenance of machine. Maintenance of machine. Maintenance means the special care given to buildings, in this case machines and other facilities, so that they can be in good working condition. Maintenance means the special care given to machines so that they can be in good working conditions. And this can be achieved through the following means. 1. Lubricating of the metal parts of a machine to reduce friction. When the metal part of a machine is lubricated, it helps to reduce friction and therefore avoid the wearing and tearing of parts of the machine. Regular cleaning of the carburetor of a machine helps to prevent dirt from blocking the jet for petrol. And again, if the oil in the machine is gauged regularly, it helps to prevent heating up and damage to the machine. Machines can be painted to prevent corrosion or rusting. Machines can be painted to prevent corrosion or rusting of the exposed part of the machines. Again, regular changing of the oil in the engine will make the engine to last longer. Regular changing of the oil will make the engine to last longer. And also, the use of ball bearings in moving parts of a machine will help to reduce friction in the machine. The use of ball bearings in the moving part of a machine will help to reduce friction in the machine. So therefore, to reduce the rate at which machines break down, they need to be serviced regularly and maintained. To reduce the rate at which machines break down, they need to be serviced regularly and maintained. So, mechanical advantage, velocity ratio, and efficiency are ways to ascertain the workability of a machine. Some machines can work better than other machines. And again, no machine is 100% efficient due to friction in the moving parts of the machine.